teacher Charlene and welcome to Study Hall. So for today's topic, I will be discussing about fractional exponents. So in my previous video, you have learned about the different laws of exponents and how you can use the different exponential laws to simplify expressions or equations. Now, for this particular topic, I will be discussing fractional exponents. Like, what if you have an exponent that is in fraction form? Now, don't get confused because basically fractional exponent just allows you to express your power and your roots together in a given expression or in a given item, okay? So the general form of a fractional exponent is given by the following. As you can see, you have a base here, b, this is your base, and you have n over m, which is your fractional exponent, okay? So in lower mathematics, you know how a fraction looks like, wherein this one is your numerator and the other one is the denominator. So in this case, n represents the exponential power, okay? This one represents the exponential power, okay? The one below it, which is the m, is your roots. So whenever you encounter an expression that has a fractional exponent, if you will want to write it in another way or to express it in another way, it just means that it has a radical sign. This is your radical sign, okay? M is the index of your radical sign. B is what you call the radicand, okay? And n is your power or your exponential power, okay? So let me give you an example, okay? To make it easier to visualize, let's say I'm going to give you a perfect square, like 2 raised to 2 is 4, okay? 3 squared is 9. So these are perfect squared. 4 squared is 16, okay? If I will write down square root of 16, okay? When there is no number here, the index means that it's 2, okay? Which means that this one, if I will write this into this type of format, then it will be 16 1 over 2. Where did I get 1? Okay, if you look at the number here, this is your radicand. There is no power, okay? So this one is only 1 here. So basically, I can rewrite this as 16 raised to 1/2. Now, I can rewrite 16 because 16 is a perfect square. I can rewrite 16 as 4 raised to 2. Yes? Okay, now this is where the tricky part comes in, and most students get confused with this. 16 is equals to 4 raised to 2, but I still have 1/2 here. So where I will put the 1/2? So I will multiply this by 1/2. These numbers will cancel out. I will get 4. Okay, now, without doing all of this, you know that square root of 16 is 4. And so, my answers are the same. So they are both correct. So reminder, keep, okay, so Don't forget the different terms in this particular expression, okay? The radicand is the number inside your radical sign, okay? The index is your root, okay? This is your index. The base is basically the b. This is your base. And the power is the n, the exponential power. Understanding the different terms is very, very important so that in the event that you get to have problem set that asks you to express in different forms, you know what is being asked from you. Okay, so let me proceed with some of the given examples to help you understand the concept more. With specific examples, okay? So let's say you're being asked to write the following expressions in radical form. So I will be giving you a different set of expressions that uses fractional exponents, and you will have to write it in radical form. Let's say for item number 1, you're given 8 raised to 1/2. Okay, so remembering in the previous lecture I said a while ago, 1 represents your power and 2 represents your root. So in this case, you don't need to write the index of your root, which is 2, because you know automatically that if it's in a radical sign and there's no number here, this one is a square root of 2. Okay, so I will write down square root of 8. Okay, now I can simplify 8. I can write 8 as 4 times 2, right? I can write this down as 4 times 2, which I can further simplify 4 to 2 squared times 2. Now, because 2 squared, I can bring out the roots. Okay, I can bring out 2 square root of 2. Okay, do you follow? So basically, if I'm going to show you another method to do this, okay, 4 is basically 2 squared, yes, times 2. This is the one I was doing a while ago. Now, square root is 1/2, so times 1/2. I can cancel this one out. So I will be left with 2 times 1 raised to 4. Okay. So let me proceed with the different examples. Let's say you're given set of expressions that are in exponential form and you are being asked to write them down in radical form. Let's say the first item is 5 raised to 1/2. Okay? 1 is your power and 2 is your root. So you write it down as, this is the index, 5 is the base, and this is your power. Now, when writing radicals, you don't need to write number 2. If the index is 2, you just write down the square root because automatically you know that it's 2. And you don't need to write the power of 1. So basically, it's just square root of 5. Okay? Let me give another example. Let's say you have 3 raised to 4 over 3. Okay? You write down the radical sign. The base is 3. Now, in item number 2, you have to write down the index of your radical sign because this is cube root. This is 3. So you have to write down 3 here. Okay? You don't need to write it down only if it's 2 because it means square root. But if it's other numbers, like let's say 3, 4, 5, you will have to write it down. And you just copy the power, which is 4. Okay, now the question is, can I further simplify the following? And the answer is yes, because I can rewrite 3 square root of 4, 3 raised to 4 as 3 raised to 3 times 3 times 1, right? You remember your exponential laws, which means that I can take out 3 here because this is the cube root. So it's 3, I can bring out 3, copy the index, I need to copy the index, and this is my simplified form, okay? Let me give another example. You have 2 raised to 5 over 3, okay? Again, you have to write down the radical sign and the base, okay? 3 is the index of your radical and 5 is your power. Just copy the given items. Okay, now the question is, can I rewrite 2 over 5? Yes, because I can rewrite 2 over 5 to further simplify this by writing it as 2 raised to 3 times 2 raised to 2, yes? Because if it's multiplication, you just add the exponents here, the one inside. Now, I can bring out 2 outside, which will give me 2 cube root of 2. Okay? Now, for some students who will still be confused, how come I can bring out 2 here? So, what happened inside the radical sign? Okay, now what I want you to do is take a look at this ones first. Okay? 2 raised to 3. Okay? If I will put a cube root here, okay, this one basically means 2/3 times 1 over 3, right? Because the radical sign represents your fractional exponent. So I can cancel this one out, which means I will be left with 2. That's why the 2 is here. Now, I still have 2 squared left here, which means that I need to further simplify this, which will give me 4, because 2 squared is equals to 4. Okay. Now, let's say you have another example, number 4. Okay. You have 7 raised to 2 over 3. Okay, again, you put the radical sign, 7 is the base, the index is 3, and the power is 2. Now, can you bring out any number, or is there any perfect square or cube root in your base or in your radicand? The answer is no, because 2 is smaller than 3. Okay, so basically this one is cube root of 49. Okay, now if this one, let's say this one is 7, 4 over 3. Then this one will be cube root of 7 raised to 4. Okay, I can write down 7 raised to 4 as 7 raised to 3 times 7 raised to 1, which means 7 cube is a perfect cube. I can bring it out, and this is my final answer. If there is no index here, then automatically it means that the index is 2. And because there is no power here, then this one is 1. So 3 raised to 1 over 2. This is the exponential form of this radical form. Okay? Let's proceed to Example number 2. If I give you square root of 3, and then you have a radicand which is 3 raised to 2. Okay. Now you copy the base. Okay. When writing it down to another form, always look at the base. Okay. This is your base. And then you copy the number here. It's 3. Okay. The index will be the one below here, which is the denominator. So you write down over 3. And this is your power, which is 2. This is the correct answer. Okay. Let's proceed to example number 3. Let's say I have the following. Okay. As you can see, based on or compared to the previous example, the whole radical expression is raised to 3, meaning there is an exponent that is raised to this whole particular term here. Okay. Now, what you do is the same process as what we have done in item number 1 and item number 2. Can follow? So, basically, you just copy the base here. And because there is no power, you just write down 1 over 5. And because the whole term here is multiplied to 3, then it means that you will have to multiply the following fractional exponents to 3. Which means that your answer should be 3 times 1 is 3, x 3 over 5. Okay, let me give you another example. Okay, let's say item number 4. Cube root of y over 4 raised or multiplied to the exponential 3. Okay, in this case, copy first the base, which is y. Okay, the power is 4. The index of your radical sign is 3. And then the whole term here is multiplied to 3. So you will have to multiply this to 3. Now, one thing you will notice in this particular example is I can cancel out 3, right? I can cancel out 3 here, which will give me y raised to the 4th. Okay? Let me give more examples. Let's say item number 5 is square root of x raised to 5 multiplied by, let's say, 3. Okay. So it's the same process. You copy down the base, which is x. And this time, you cannot use 1 because there is a power here. So there is a value in your numerator of your fractional exponent over 2. Because this one, it doesn't have any, which means that the index is 2. And then you multiply it all by 3. Okay? So in this case, you just need to multiply 5 times 3, you get 15 over 2. Okay? Let's proceed to number 6. Let's say you were given square root of a raised to 4 raised to 2. Okay? Again, you copy the base. You copy the base, which is a. And then you copy the power, which is 4. And because there is no number here, it means it's square roots, which is over 2 here. Now, multiply this by 2. This will cancel out. The answer is a raised to 4. Okay. Now, one thing you will notice is whenever you raise the whole term in the same value of the index here, the whole radical sign is cancelled out. Let's say if I give you square root of 3x and then I will multiply this with an exponential 3, this one will just be x. If it's 4 here and then I will multiply it to 4 as well, this one will be x. So you see the pattern?